How you doing? I'm Nicholas Fowler, and I'm with Christina Collins, and we're here to present you our physics project. Now, people ask me why I do things I do, and I come and answer their question like, I don't know. Back home, for fun, we mud, we tractor pulls, we pull each other with our trucks. Well, today, I'm here to show you some clips of what we do. So buckle up and prepare. Yeah! That right there, my friend, is called mudding. People think it's stupid, but it's actually fun. The objective is to get stuck and get the truck dirty so you can show everybody else in town.
Now the physics part of it. As you can see, the smaller truck got stuck in the mud because there was not enough friction between the tires and the ground to get it out. When you're mudding and you don't have mud grips, going through the mud is basically like walking on ice in just regular shoes. You're not going to get very far. The other truck, when it tried to pull it out, also didn't have mud grips. Even though it was on a slightly more solid ground, it was not able to pull it out because, once again, there was not enough friction between the wheels and the ground. The truck that was trying to pull it out was a 6-liter F250. If it had been, say, an F350 or maybe even a tractor, it would have had a higher chance of pulling the smaller truck out of the mud because it would have had more power and more force behind it, helping it out. Another issue is the rope that was tying them together had too much tension pulling at it to stay together and help pull it out.
That right there, my friend, is some fun action. You saw two trucks trying to pull each other and one won and one didn't. So now we finna go to the physics.
Now you would think that because the yellow 18-wheeler has a higher mass, it would be able to drag the red truck across the yard. And yes, it should be able to because since it has a higher mass, it also has a higher normal force, which means it's going to have friction working in its favor. But according to the equation, force equals mass times acceleration, it is possible for the red truck to be able to drag the yellow 18-wheeler because it probably, or most likely, has a higher acceleration. Now with this, it means it has a higher force, and so with the tension between the rope, it means the force is going to be working in favor of the red truck, which allows it to pull the yellow 18-wheeler.
Alright, from the first video we showed you, the F250 was stuck in mud and the wheels kept spinning. The F250 weighs about 6,400 pounds, and that's 2,902.99 kilograms. The coefficient of static friction of mud is around 0.59, and then we figured out that the acceleration of the truck was about 3.2 meters per second squared. So, finding the normal force, we said N minus mass times gravity equals 0 because it's not moving vertically. And so N is equal to mass times gravity. So you substitute mass times gravity in for the friction force. So you have static friction force is equal to mu s times mass times gravity. You plug in 0.59, the mass of the truck, and gravity, and you get that the static friction force is equal to 16,785 newtons. And then you have to find the force that the truck is generating to move forward. And you take the mass that it is and times it by the acceleration. And that force the truck creates is 9,289.568 newtons. And since the frictional force, which is static friction, is greater than the force created by the truck is just going to keep spinning in the mud, and that's why it didn't move.
Okay, so in the tug of war video, we saw that the Chevy Silverado was able to pull the semi-truck. And normally you wouldn't think this was possible since the semi-truck weighs about 15,000 kilograms and the Chevy Silverado only weighs 13,200 pounds, which equates to 5,987.419 kilograms. However, if the semi-truck were to have a lower acceleration than the Chevy Silverado, then it would be possible for a smaller truck to pull the bigger one. So when we solve for the equations for the semi-truck, we plug in for the equation force is equal to mass times acceleration, which comes out to be about 13,500 newtons. And then for the Chevy Silverado, when we solve for force equals mass times acceleration, we get that the force came out to be about 13,771 newtons. So when we compare these two, we can see that the force created by the Chevy Silverado comes out to be greater than the force for the semi-truck, which allows the smaller truck to be able to pull the greater mass truck.